Welcome to Spring Lib.
In this problem, we're given the angular position or the rotation of an oscillating flywheel as a function of time. So that's this expression here. And we have to calculate the angular coordinate, the angular velocity, and the angular acceleration of the flywheel at t equals 0 and t equals 0.125 seconds. So this really comes down to just being a calculus problem, where we know the angular velocity is the time derivative of the angular displacement. So we can go through the calculus and get this. I'm not going to go through all the details of the calculus. I'm assuming that you can do that or use a computer to do it. And then the angular acceleration is the time derivative of the angular velocity, and we can go through all the math and calculus to get this expression here. We're told that theta naught is 0.5 radians. So at this point, it's just a matter of plugging in our values. So at t equals 0, cosine is 0 is 1. E is 1, e to the 0 is 1, so we get theta is 0.5 radians. So theta is theta naught, and that's why we call it theta naught, because that's theta when t equals 0. Plugging in theta naught and t into this expression here, and just crunching through the algebra, or crunching through the math, we get that omega is minus 4.7 radians per second. And then plugging everything in the acceleration, we get that the angular acceleration is minus 34.5 radians per second squared. Now, if we use t equals 0.125, which is 1 over 8, plug that into here, we see that we wind up getting cosine of pi over 2, which is 0. So that means that the angular displacement at this time is 0. We can plug everything into here, and again, this term is going to be 0, but this sine term is going to be 1, and then this is going to be something, and everything gets kind of messy. But we just go through the math, plug it all in the calculator or the computer, and we get that omega equals minus 1.9 radians per second. Plugging everything into here. Again, we can just crank through the calculations, and we get that the angular acceleration is 36.7 radians per second squared.